Earthquake and tsunami. These two words are seen to be appearing synonymously with the Pacific Ring of Fire. This is what is being observed in this article, which says that Alaska hit with 6.2 magnitude earthquake, which is the second major quake in a week. Now, what is the context here? The context is the Alaska earthquakes, which have occurred in July 2025. The first earthquake occurred on July 17, 2025, which had a magnitude of 7.3 and a depth of 36 kilometers. Now, this particular earthquake, it triggered a tsunami warning for coastal Alaska, but later it was downgraded to an advisory. The second earthquake, it happened on July 21st, 2025, which had a magnitude of 6.2 and a depth of 48 kilometers. It occurred in the Alaska Peninsula and it sent likely aftershocks due to intermediate depth. Now, if you look into details, tsunamis occur due to earthquakes. Now, what is a tsunami? A tsunami is a series of ocean waves that are caused by displacement of large volume of water, typically in an ocean or a large lake. Now, undersea earthquakes at convergent subduction, that is, if you see this diagram, so undersea earthquakes at convergent subduction boundaries are the most common cause of tsunamis. So, what are the favorable conditions for tsunamis to form? Now, we need an earthquake of magnitude more than 7.0 on the Richter scale. We need shallow focus earthquakes, which were seen in the case of Alaskan Peninsula, whose depth were less than 70 kilometers. We need an epicenter that is located under the ocean, and we need these earthquakes to occur at the convergent boundaries. Now, if we look at the seismological aspects, then the earthquakes causing tsunamis usually occur along reverses or thrust faults, and tsunami waves are nothing but they are shallow water waves that are affected by ocean depth and not wind as such. Now, what is the process of tsunami being created because of earthquake? First, the tectonic stress builds up at subduction zone. There is sudden fault rupture that causes vertical displacement of ocean flow, because of which the water column is displaced and a wave energy radiates in all directions. In case of deep oceans, the wave height is low, but the speed is very high, that is up to 800 kilometers per hour. But as the wave reaches near the coast, the waves they slow down, but the height increases drastically, which creates a destructive impact. Now, looking at the geographical significance of Alaskan Peninsula, now this particular area or region is located on the Pacific Ring of Fire, which is a highly seismically active zone due to multiple plate boundaries. Now, understanding the tectonic setting of Alaskan Peninsula, it is at the convergence between the Pacific plate and the North American plate. There is a subduction zone present here, which is the major source of earthquakes and tsunamis. Now, if you look at the historical precedent of this particular region, then this region has witnessed the 1964 Great Alaska Earthquake, which had a magnitude of 9.2, which is the second largest recorded earthquake globally. And this region is known for its frequent seismicity and active volcanoes. Now, if you understand the disaster implication and the management, then there is high tsunami risk because there are earthquakes of more than 7 magnitude, and that too it happens in the shallow waters, which can trigger continuous tsunamis. Now, there is very high importance of early warning systems in this region, like the US Tsunami Warning Center, whose role becomes very important here. Now, there are aftershocks and ground ruptures. Aftershocks likely due to intermediate depth, that is somewhere between 36 to 48 kilometers, and there is high infrastructure damage risk in this sparsely populated but strategically located area. Now, if you look at the exam relevance of this article, then we have different GS topics like geography, where we study the earthquake prone zones, their distribution both with respect to static and with respect to map based questions. Then we also study plate tectonics and seismic hazards. Now, under disaster management subject, we study topics like early warning system and international cooperation, mitigation measures for high magnitude earthquakes, where this particular case study, that is Alaska Peninsula 2025 earthquake series, can be used. There is a very common quote which says that earthquakes don't kill people, buildings do, which can be commonly used in any of the answers with respect to disaster management. Now, what is this Pacific Ring of Fire? Let's try to understand in detail. The Pacific Ring of Fire is nothing but a horseshoe-shaped zone that is encircling the Pacific Ocean, stretching for about 40,000 kilometers. It is recognized as the most seismically and volcanically active belt on Earth, that is accounting for almost 90% of the world's earthquakes and 75% of its active and dormant volcanoes. If you look at the geographical spread, the Ring of Fire extends from west coast of South America, that is the Andes Mountain and the Peru-Chile Trench. Then it goes through Central America, the west coast of North America, including California and Alaska, which we just discussed, across the Aleutian Islands of Alaska to the coast of East Asia, that is Japan and Taiwan. Then it goes into Southeast Asia, that is Indonesia and Philippines, and down to the New Zealand. If you look at the map of Pacific Ring of Fire, it starts from here, that is the west coast of South America. It goes all the way to North America, that's Aleutian Islands of Alaska, that's Japan and Taiwan, and it goes till New Zealand. Now, this is a zone of intense geological activity because the geological activity is primarily result of plate tectonic processes, especially the convergent boundaries where oceanic plates are subducting beneath the continental plates. So the key tectonic plates involved here are the Pacific plate, the Nazca plate, the Costco plate, the North American plate, the Philippines plate, Eurasian plate, and the Indo-Australian plate. All these plates can be seen in this diagram, that is the Pacific plate, Nazca plate, Costco plate, Philippine plate. So at the subduction zones, the denser oceanic plates, they sink beneath the lighter continental plates into the Earth's mantle. That creates friction and there is pressure built up, and eventually there is release of massive amount of energy in the form of earthquakes. Now the subducted plates, they melt due to high temperatures and high pressure. that give rise to volcanic arcs and undersea volcanic mountains, some of which grow into islands over time. Now, as we have seen that this particular zone is prone to catastrophic natural disasters, so the Ring of Fire is nothing but home to some of the most catastrophic natural disasters in history, like the 1964 Great Alaska Earthquake, which had a magnitude of 9.2, the 2004 Indian Ocean Earthquake and Tsunami, the 2011 Tohoku Earthquake, which happened in Japan, which had a magnitude of 9.0, which caused the Fukushima nuclear disaster also. Now, similarly, deadly volcanic eruptions like Mount Pinatubo in Philippines and Krakatoa are also tied to this region. Now, above events, they highlight the tsunami generating potential of undersea megathrust earthquakes in the Ring of Fire. Now, from a disaster management perspective, the Ring of Fire underscores the critical need for understanding early warning systems, the need for earthquake-resistant infrastructure, the need for tsunami surveillance networks and international cooperation, particularly through platforms like Pacific Tsunami Warning Center and UNESCO's Intergovernmental Oceanographic Commission. Now, for countries like Japan, Indonesia and even USA, that is the California and Alaska region, we need continuous monitoring of seismic activity, which is crucial for saving lives and minimizing economic losses. If I want to conclude this discussion, then we can see that in essence the Pacific Ring of Fire is not just a geographical feature but a dynamic and potentially destructive natural system. It serves as a vital case study for understanding plate tectonics, natural hazards and the interaction between geophysical processes and human settlements. Now, in the context of different competitive exam syllabus, it offers a rich material for integrating physical geography with disaster preparedness and management in both general studies and optional subjects. So friends, I hope this discussion would have been helpful for you in your exam preparation. Thank you for listening to us and please subscribe to our channel for more such content. Thank you.